All right, hey guys, welcome to Chapter 4. In Chapter 4, we're going to start talking about polynomials and polynomial functions. And there's just a whole lot of information on this page we're going to go through really quick here. Hopefully some of this vocabulary is things that you know already. So we have a monomial. Monomial means there is one term. So for example, if you only have one term, there's nothing being added or subtracted together. So a monomial would be something like 3x. Or you could have 5xy squared. Or you could have negative 3xyz. As long as everything is being multiplied or divided, it's still a monomial. When you start to have having things added and subtracted and things like that, it can start to be a binomial, trinomial, or whenever we're talking about just a bunch of terms together, we give the general description of a polynomial. And we have a binomial has two terms, and we've been doing quite a bit when we factor with binomials. So for example, x plus 2, that's a binomial. It has two terms. 5x minus 3z, that is a binomial because it has two terms. Three terms, you guys get the idea, would have three terms in it, so you'd have x squared plus 2x minus 1. That has 1, 2, 3 terms in it, separated by addition and subtraction. A polynomial is just our general description of any number of terms. Okay, so then a lot of times when you do these polynomial functions, they're going to ask you to put things in standard form. Standard form just means you're writing all of the terms and you're starting with the highest exponent and you're going in descending order. So highest exponent first, then the next highest, then the next highest, and so on. The other thing we'll ask about is a leading coefficient. A leading coefficient is once you have it in standard form, the lead coefficient is the term or the coefficient of that first term. So quite often when we did like quadratics and things like that, our lead coefficient was our a value, because in standard form it was ax squared plus bx plus c for quadratic. So that a value, and that a value, if you remember, tells us some stuff about the graph, if it opens up or if it opens down. And then the degree of a polynomial, the degree is just the value of the highest exponent. And then the other thing we are going to talk about today is whether or not a polynomial is or is not a function. And in order for a polynomial to be a function, all three of these things have to be true, which means if you have exponents in there, the exponents have to be whole numbers. There can't be any negative exponents, can't be any fractional exponents, can't be decimal exponents, anything like that. Exponents cannot be variables, so you can't have like 3 to the x or something like that. And the variable cannot be in the denominator of a fraction. So those are some key things that as we go through, we're going to keep referring back to this. So this might be a slide that if you're struggling with some vocabulary things that you could come back to. Okay, so then some different types of polynomial functions based on the degree. Remember, the degree is just that highest exponent value. So if you have a degree of 0, that means you have like x to the 0 power, which would be just a horizontal line, and it would be like y equals a number. Okay, so that's called a constant. And then if you have a degree of 1, that's linear. Okay, linear we've done a lot with linear equations. That would be in a form looking like this, like y equals mx plus b, like the example is 5x minus 7. A quadratic, we've also spent some time doing quadratics, so that's a parabola, and it's going to have an exponent of 2, a highest exponent, or a degree of 2. And some that we have not talked about yet is cubics, which we'll talk more about as we move forward here, which has a degree of 3, so the highest exponent is a 3. And then a quartic has an highest exponent or degree of 4. So those are some new vocabulary words that you're going to need to become familiar with, particularly constant. Maybe you don't always think about it that way. We should know linear and quadratic, but cubic and quartic are some new vocabulary for you. Okay, so what we're going to do, there's a lot of things going on here. We're going to first of all decide whether or not each function is a polynomial. If it is a polynomial, we're going to write the standard form. We're going to state the degree, the type, and the leading coefficient. And if it's not a function, then we're not going to do any of that. We're just going to say not a function and we're done. So if we look at the first one, we have to ask ourselves, is it a function? Remember, if it's a function, it can't have any it can't have any negative exponents, it can't have any variable exponents, it can't have any variables in the denominator. So if you look at all of those things, we can say that this first one, yes, it is a function. Oopsies. And second thing we need to do is put it in standard form. So highest exponent first to lowest. And if you look, the highest exponent is 3, and then it goes to the x plus 8. It's already in standard form, so I'm not going to rewrite that. The degree is the highest exponent value. In this case, the degree is 3. The degree tells us the type. So in this case, a degree of 3 tells us that we have a cubic, so the type is cubic. And then the lead coefficient is -2. And when we start talking about lead coefficients and things like that, when we start looking at graphs, that's going to tell us some things about the graph as well. So that's kind of important to remember. This second one here, I've got a little bit stuck, there we go, is we need to see if it's a function. So to know if it's a function, we're looking at our exponents. We have exponents of 4 and 3. There's no negatives, there's no fractions, there's no anything like that. So yes, it is a function. Sometimes kids like to think that since there's a square root of 2 in there, that means it's not a function, but it's fine. The square root of 2 is just a number. And to put it in standard form, we would need to go highest exponent first, which is x to the 4th. So we're going to say the square root of 2, x to the 4th. Our next highest exponent is 3, so we'd have minus 0.8 x to the 3rd minus 12. Since it's a fourth power, if we look down here at our table, fourth power is called a quartic. Well, that's the type, sorry. Here we have a degree of 4, because that's the highest. It's a quartic. And the lead coefficient is the square root of 2. So what I'd like you to do is pause the video for just a second here and try to figure out these last two, number C, or letter C and letter D, and then check to see if you are correct. Okay, so if you take a look, letter C is not a function, so we don't need to answer any of the other questions. And then letter D, you can take a look at and see that it is a function and it's already in standard form and stuff. Okay, so then we need to think about, we're going to talk about the graphs of these polynomials. And there's constant, linear, quadratic, cubic, quartic, which we talked about what those look like algebraically. If we're looking at a graph of those, okay, if we're talking about a constant has a degree of 0, okay, so it has a degree of 0. And it's in the form of y, or f of x, equals a number. And it is a horizontal line. So it's going to look something like that. Okay. If we are looking at a linear means it's a degree of 2. Okay. And we think about lines, they either have a positive slope or they have a negative slope. And if we think about our lead coefficient, okay, our lead coefficient, which we talked about on the last slide, if it's going up, that means it's a positive lead coefficient. If it's going down, it's a negative lead coefficient. Same thing with quadratics. Oops, I'm sorry, go back to the linear. Linear has a degree of 1. I said the wrong thing there. Linear has a degree of 1, not 2. Sorry about that. Quadratic has a degree of 2. And when you look at a graph of a quadratic, it's either going to be opening up or it's going to be opening down. And again, with our lead coefficient, the number out in front, okay, if it looks like that, it has a positive lead coefficient. If it looks like that, it has a negative lead coefficient. That A value is positive, it opens up. The A value is negative, it opens down. Cubic, we haven't really looked at cubic graphs other than with our Desmos project. Cubic is a degree of 3. Okay, and our graphs look something like that. Okay, that's the general look. And so this is what it would look, well, actually, or they could look like this, something like that. Okay, and when we're talking about the lead coefficient, coefficient. If it looks like that, it has a positive lead coefficient. If it looks like this, it has a negative lead coefficient. So if it's going up from left to right, it's going up as you look at it left to right, it's got a positive lead. If it's going down from left to right, it has a negative. Okay, and a quartic, my guess is you've never really seen that. It's a degree of 4. And it looks something like this. You have something that looks kind of like that, or you might have something that looks kind of like that. Okay, and if you think about it logically, what we, relating it back to the quadratic up top, if we're talking about a lead coefficient, okay, think about which one would have a positive lead coefficient and which one would have a negative. Well, this one over here opens up, so it has a positive lead coefficient. This one over here opens down, so it has a negative. Okay, now one of the last things we're going to talk about here is the end behavior of these. End behavior just means what's it doing at the arrows. Okay, so first of all, we want to know if we can just look at a graph and know if the degree is odd or even. Okay, if a degree is odd, okay, notice these top two are both odd. If you look at them, kind of think about what do you notice about what they have in common, and hopefully you notice that on odd degrees, they always have one end is going down and one end is going up. Okay, so when you have one that's going down and one that's going up, one that's going up, one that's going down. So if they have an odd degree, that's how you can tell they're going to be going basically in opposite directions. If they are even degrees, like quartics and quadratics, that means they are both going in the same direction. Notice they are both going up on this one and they are both going down on that one. So the general graph is going to look like something like that. And then the other thing is, think about here, if you have a lead coefficient that's positive or negative, if you notice on this one on the left right here, okay, has a positive lead coefficient. I know that because if I read my graph from left to right, okay, I start down here, I'm reading it from left to right, and in the end I'm going from lower to higher. I'm going in a positive direction. If I look at the other one, I start up here, I start at the top, and I end down low. So that's going to be negative. It's going down from left to right. If I'm thinking about these down here, positive versus negative, it's the same idea as a quadratic, where if they are both opening in the positive direction, then it has a positive lead coefficient. If they're both opening in the negative direction, then it has a negative lead coefficient. Okay, and then the other thing we're going to talk about is the end behavior. That end behavior is basically what's happening at the ends, and they put it in terms of, so let's zoom in on one of these here. If we look at our end behavior, it says f of x approaches negative infinity. That's what we say there. And really when we think of f of x is just another, it's function notation for y. Okay, so if you ever get confused, think about x and y. So y approaches negative infinity. Remember, y is the up and down part. So if you look, it is going down, so it is going towards negative infinity. And x, remember, is left and right. X is also approaching negative infinity because as it's going down, it's going in that general direction. It's going to the left. So it's approaching, x is approaching negative infinity as well. If we look at this one over here, okay, we have y is approaching positive infinity. So this, let me highlight, this end right here, y is approaching positive infinity because it is going up, our y value is going up, and our x is approaching negative infinity because in general the graph is going in the direction to the left in the negative direction, so it's approaching negative infinity. And then on the other end down here, this end, y is approaching negative infinity because it's going down, and x is approaching positive infinity because it's going in the positive to the right direction. And I kind of forgot over here about this other end. This end right here, okay, y, it's going up Okay, if you follow the arrow, y is going up, the up and down, and x is going in the positive direction as well. So y is approaching positive infinity and x is approaching positive infinity. And then we have this one down here, okay, this end right here, okay, y, f of x, y is approaching positive infinity, and x is approaching negative infinity. And then this one you have y is going up, so it's approaching positive infinity, and x is heading towards the right, which is positive, so it's going towards positive infinity. And then if you look at this one here, y is going, follow the arrow, it's going down, so it's going towards negative infinity, and x is going to the left towards negative infinity. And then same thing over here, y is going down, so it's approaching negative infinity, and x is going to the right, which means it's approaching positive infinity. Okay, so we're going to actually look at a couple of these examples and decide if just by looking at the graph, if the degree is odd or even, if the lead coefficient is positive or negative, and then we're going to describe the end behaviors of each of them. So looking at the first one, let's decide if it's odd or even. Well, we have both of the ends are going in the same direction. They're both going up, so we know that it is going to be even. And in order to know if it is positive or negative for a lead coefficient, remember if they are both going up, that means it's positive. Both going down means it's negative. So in this case, it would be positive. And if we look at our end behavior, f of x, which is y is going up, so it's approaching positive infinity. Oops. And x, as x is continuing, it's heading towards negative infinity. And on the second one, again, f of x, which is y is heading in the up in the positive direction towards positive infinity. And x is going up and out, so it is also heading towards positive infinity. Okay, let's look at the second one here. We have, first of all, I noticed that one end is going up, one end is going down, which tells me that it is an odd degree. That's how one way we can tell. And the lead coefficient, if I look from left to right, if I follow my graph, it starts high and it ends up going down. It is going down from left to right, so it is a negative lead coefficient. And if we look at our end behavior, so let's look at this end behavior up here. Our y value is going up, so that means it's going in the positive direction towards positive infinity, and x is also going to the left, which means it is going towards negative infinity. This end on the other end down here, the y value is going down, so it's going towards negative infinity, as x is going towards positive infinity. Okay, why don't you go ahead and try these two, look at the graphs, decide if they are odd or even with the coefficient, the lead coefficient, if it's positive or negative, and then find the end behaviors for both of them, which are kind of started out there for you, and check back and see how you did. Okay, so go ahead and take a look and see what you got and see if you agree. If you have questions or aren't quite sure with what it is, please ask. Okay, so the last thing that we are going to do is actually practice when I give you some zeros and some information about a graph so you can kind of see how it actually works. So we have here on the graph here, the first thing is it's an odd function. So if it's an odd function, we know that it's going to do something going in opposite directions. It has zeros at -3. We'll put zeros there, +2 and +4. It's kind of hard to read those numbers. It has a positive lead coefficient, which means it's going to do something where it goes up and goes in opposite directions. So what we look at what we have here, I know it needs to start down low, come back, and do something like that. How high this maximum part here goes and how low this minimum part here goes kind of depends on the equation and things like that, but it has an odd function because it goes in opposite direction. It has the zeros, it crosses the x-axis at those 3 places, and it has a positive lead coefficient, so because we know that because it's going up as we with our end on the right. So we can kind of just sketch a general graph like that. So why don't you go ahead and see if you can try these other two and see if your graph looks similar to mine when you're done. Okay, so take a look. If you notice on this first one that I sketched, it's even, so they're both going in the same direction, heading down because it's a negative lead coefficient, and it crosses the x-axis at those 4 locations. Same thing on the other one. It has an odd function, so it's going in opposite directions. One end's going up, one end's going down. Real zeros, I have all 4 of those places, 5 of those places marked on my graph on my x-axis where it crosses, and it starts in quadrant 2, just like it says. Okay, so you should be able to find a Big Ideas online homework assignment that you can finish over this topic.